Okay. I would like to thank distinguished panelists and the distinguished chair for this, I think, very important discussion. I mean, which is penetrating through all possible activities and in the project, etc., of the HFSP in the future as well. Now, HFSPO has been proud to support projects which led to many prizes, but which also, maybe surprisingly, created a number of groundbreaking economic and other innovations. And this is from the projects which were not meant to do so, because high risk, high gain project cannot promise upfront, you know, if you give me money, I will cure Alzheimer, for example. We are not requesting such a language at all in our project. Nevertheless, independent analysis, which was done some years ago, showed that number of patents coming from the project we are supporting is actually higher compared to the mainstream funding. This is interesting fact, I think, which is also discussing. I am very proud that we have now next panel with the experts on this particular issue of innovation and basic science, chaired by Steve Wesselingh. Professor Wesselingh is the CEO of the National Health and Medical Research Council of Australia, and he's also representing Australia on the HFSPO Board of Trustees. Steve, please join us on the stage here. And he will be joined by distinguished panelists. To start with, Professor Mishima, President of the Japan Agency for Medical Research and Development, AMED. Also, our distinguished trustee on the HFSPO board. We will have Dr. Eric Green. Eric is Director of the National Human Genome Research Institute of NIH, and I think also a great supporter of HFSPO world. Eric, please join us here. And finally, like in previous panel, we will have our own HFSPO awardee who will share his experience from the innovation potential of the HFSP support. That's Professor Henry Hess from Columbia University in New York, and he is a HFSP research grantee from 2021. I will turn over to Steve now. Steve now to take over the panel.
Thanks very much. And we have the problem of being the last session, the last half an hour between you and alcohol and food. So, but we'll try and keep you entertained. I also have the challenge that I arrived at 3 a.m. from Australia this morning, so I'm not sure whether my brain's clearing protein or my brain's still in Australia. So, but I'll do my very best. And we also have a pre-recorded view on this from Victor Dzau, so we'll be doing that in just a second. But I thought I'd just start by highlighting the importance of fundamental and basic discovery life sciences. And I guess just ponder a little bit. There was an interesting article in The Economist last year which suggested that although we might be spending more on research, perhaps we're doing less innovation, and perhaps we're doing safer research, perhaps we're doing research that is very much directed at the challenges that we see, the health challenges and others. But as already indicated, it's really the high-risk research, the research that we don't know the results of, that we don't know the impact that it's going to have, the research that's driven by imagination, that really is going to help us the most, I think. The other challenge we have, obviously, is how do we select that research? How do we rank that research? And I certainly know in my own area, I'm an infectious diseases physician, that genomics changed microbiology dramatically, and then metagenomics changed our view of the microbiome. So both of those fundamental changes, and maybe Eric might want to comment on that. But to start, I think we have a pre-recorded short comment by Victor Dzau, the President of the National Academy of Medicine here in the United States.
Good evening. I'm Victor Dzau, President of the National Academy of Medicine. And it's a great pleasure for me to provide the opening remarks for this important session on the future of discovery life science. I'm grateful to International Human Frontier Science Program Organization for creating a forum for experts around the world to coordinate and discuss this important topic. You know, discovery is a major engine for innovation and societal transformation. In the last 50 plus years, we've witnessed major advances in life sciences, starting with discovery of DNA double helix in 1953 that led to the era of molecular biology, and then the completion of Human Genome Project in 2003, leading to what's known as the genomic revolution. The last decade, we've seen amazing discoveries that have truly transformed science and medicine. These include genome editing technology, immunotherapy, regenerative medicine, advances in digital technology, robotics, automation, and artificial intelligence, to name a few. We are truly now in the era of convergence, where all these disciplines come together to solve critical and perplexing problems. Take, for example, the use of AI in protein design. It bridges computer science, biochemistry, and holds promise for drug development. I think convergence, when you bring all these disciplines together, holds immense potential for improving human health. At the launch of Chen Zuckerberg Initiative in 2018, the founder set the ambitious goal to cure, prevent, or manage all diseases by the end of this century, 75 years from now. I believe the impressive pace that we're moving, this is plausible and even possible. Just think back 75 years ago, all things we didn't have, and where we are today. We now have technology that can cure disease, regenerate tissues, and we have AI that can also change the way we think, we work, and revolutionize medicine altogether. To me, the real important question is, will everyone have access to innovation and benefit from them? So as we envision the potential of discovery science for the future, there's so much for us to consider. We must ensure that the benefits of science are equitably shared across society, and not just the privileged few, the wealthy individuals and wealthy countries. The next era of discoveries requires early consideration how emerging technologies will be used and applied equitably everywhere. In my opinion, the convergent science in the 21st century must include social, economic, ethical population science, in addition to biomedical, computation, and others, because these can amplify the impact and the social benefits of discovery science. So in summary, I strongly believe that basic discovery science is a key engine for innovation in the 21st century, the title of this panel. However, for discovery science to meet its full potential for humanity in the 21st century and beyond, I believe we must address the issue of equity and social good. Thank you again for asking me to speak. I wish you a most successful panel.
I'm sure Victor will appreciate the applause, and there were some really good points made there. But Yoshino, perhaps you could introduce yourself and then address some of the points that Victor made.
Well, hello everybody. I'm president of AMED, the Japanese funding agency for medical and healthcare. And I am a board of trustee of HFSPO, and I'm really proud of this position. And also another board of trustee from Japan is a current president, Professor Nagata from the Osaka University. So we both really proud of participating on this HFSPO. As 35 years ago, the Japanese government established this system. Okay, so let me introduce a challenge the Japanese AMED is has launched a new program, and this is a program for accelerating the realization of regenerative cell medicine and the gene therapy in 2023. So I introduce this. This program will promote the criterion of breakthrough seeds that will lead to next generation medicine, promote their clinical application and the commercialization, promote further integrated research in regenerative cell medicine and gene therapy, promote R&D and infrastructure development in these fields, and provide support for their practical application as well as elucidate disease pathogenesis mechanisms and conduct drug delivery research, discovery research. But in order to translate research results into practical application, we need very important items. It is necessary to obtain social consensus on bioethics and the protection of personal information to meet various regulatory standards, and to acquire appropriate R&D with a view to future commercialization from the early stage of research. And we'll also establish a support system for commercialization strategies, including intellectual property rights. So for all these challenges, AMED is driving now, just started, but we are now moving toward this success of this project. Okay, thank you very much.
Thanks very much for those comments. We might move on to Eric, and perhaps Eric, you could introduce yourself and obviously comment on some of Victor's points, but also perhaps, I mean, genomics has been one of the fastest growing areas of medical research, but I do wonder whether we're now very much at that translational phase. We're moving it into healthcare. How do we make sure that the sort of fundamental science of genomics still continues, and we get people asking those truly fundamental blue sky questions in genomics? Eric.
Yeah, so, is it? I don't know if this is on. Is that better? There we go. That's better. Well, thanks, Steve. You set me up nicely, as did Victor, to talk a little bit about genomics. My background is one where I built a career on genomics. I got involved in the Human Genome Project actually as a young physician scientist, just having graduated medical school, and have been involved in the field since. I came to the National Institutes of Health about 30 years ago. And for the last nearly 15 years, I've run the institute at one of the 27 institutes and centers at NIH that's responsible for genomics, the National Human Genome Research Institute that was created to run the US's effort in the Human Genome Project. It's actually interesting. I come to a conversation regarding what I've heard this afternoon and anything related to HFSP with a very different view, I think, than a lot of people, because I grew up in a project that brought multiple funders, multiple disciplines, multiple countries together to accomplish the goals of the Human Genome Project. But then all of those funders and all of those efforts, they sort of went various ways. It wasn't quite as organized. And there are various examples of funders coming together to accomplish things in genomics. There hasn't been a grand unifying plan for this. And I think one of the great challenges that we face now in really seeing innovation, both in basic science, but also leaning into using genomics and other omic technologies to really see advances in our understanding of health and disease, eventually into healthcare, is going to be the use of data. And I think the biggest transformation I've seen in the 21 years since the end of the Human Genome Project till now is we have really seen, in part because of genomics, but in part because of other technologies that have similarly resulted in the generation of prodigious amounts of data, that we've gone from life sciences being reasonably data poor enterprise to now being data overwhelmed. And there is not, practically, there must not be a researcher funded by NIH or funded by HFSP or funded any of the funders that are here involved in HFSP that doesn't use data like water or electricity, where they literally assume it's going to be available, and it's going to be available very organized. And actually, one of the things I get very concerned about now is the threat that I think there is to the stability of these data resources we all rely on. And that has very much come up to situations I've confronted with things we support at NHGRI or supported NIH, and when we looked around with some of the challenges around sustainability, we realized there were no groups interacting. And yet that was going to be groups in terms of funders globally interacting, and yet globally we all use the same data resources. And so this was an example where somebody who first grew up in an environment where funders were highly interactive, I found myself in a situation where I was shocked that funders were not interacting globally around something that is now fundamental resource that we all rely on. And that's how I got involved with HFSP. Tara Schwetz, in her remarks, mentioned the Global Biodata Coalition, which HFSP has helped to stand up and is a major supporter of, and I'm very involved in trying to help bring together funders and talking to one another about something that I think is going to be fundamental in seeing this innovation in the 21st century we're talking about. And so, again, I think this is really an important thing to be excited about, and you hear about AI, and you can think about all these potentials, but I don't think we should take for granted the fact that in order to have that electricity, that water, that data access has got to be preserved. And I think we as a global community of funders need to be thinking about how best to preserve that.
Thanks very much, Eric. Thank you. Henry, would you like to introduce yourself and also, again, address anything that you heard Victor say that you wanted to comment on, but also perhaps just comment on when you're mentoring students and postdocs or the people you work with, how do you get them enthused and how do you get them to imagine things that no one else is imagining?
So, my name is Henry Hess. I'm at the Biomedical Engineering Department at Columbia University. I grew up in East Germany under communism, then studied mostly in Berlin and got my PhD at the Free University of Berlin, and then came to the US first at the University of Washington on the West Coast, then at the University of Florida in the South, and now at Columbia University in the Northeast. And I went from physics to bioengineering to material science to biomedical engineering now. And I'm generally confused about the big picture, but I want to amplify what Dr. Green said. It's amazing how much we rely nowadays on all these databases and all these resources which are just part of the daily work, and you don't even think about it anymore, but they're like the plumbing of the whole, which holds everything together. I also think the Japanese government has shown tremendous leadership by setting up HFSP and really filling a niche, because when I made friends with a Japanese professor, Israeli professor, there are not many places where you can, well, there's basically only one place, and that's HFSP, where you can go and say, we would like to do a project together. And then the question was, how do I motivate my students to think great thoughts? And I have no idea. I just hope for the best and talk to them.
Okay, thanks. Perhaps I'll go back to Yoshinao. You were talking about the program that you've developed in Japan. What do you think are the best mechanisms for identifying the very best science to fund? To fund.
Oh, that's a difficult question also, but yeah, the Japan AMED is running about 2,000 and 3,000 project every year. So each field is equally important, I believe. But at this moment, I think the AMED is really putting a focus on cancer and the rare disease, and then recently for the dementia. And for all those, developing the drug, medicine is very important, as everybody says. And one of the very difficult thing to establish this as early as possible to develop the medicine to a patient is different in mindset of basic researchers and industries, you know. So we are trying our best to how this program should be smoothly moves into the final, you know, this kind of method is very important. And so the important, many areas we are working on by the project is equally important, but the most difficult part is this smooth shift from the basic research to practical use. Yeah. So I don't know this answer, but the most important we working really hard is this transition from research C's to practical medicine development.
I saw Eric's eyes light up there, so I'm just going to go to Eric.
Yeah, no, actually, a thought occurred to me. We've never met, but you didn't answer your question because you're modest. Because I want to tell you the way I think you inspire students and your trainees. It's because you just told me, and you just told the audience that you came from multiple disciplines, and so you bring to a biomedical or a life sciences problem or question your interdisciplinary expertise. And there's actually a theme here that I think is really important because it's one of the things that HFSP does so well. And I'm very appreciative of this because I want to remind people, not everybody realizes, the success of genomics, which Victor mentioned, Steve, you mentioned, it wasn't like we had a field of genomics and we had all these genomicists. I mean, the field didn't exist until '87, that's when it got named. The Genome Project began in 1990, 3 years later. It's not like we trained genomicists in 3 years. In fact, everybody that came into genomics for the Human Genome Project were scientific immigrants from other disciplines. And the secret to the success of the Genome Project was the fact that we embraced an interdisciplinary mix of scientists of multiple different backgrounds all trying to solve the same problem. And I think that's what HFSP tries to encourage to do in their granting program, which I think is secret success. And I think the reason you probably get great trainees and inspire them is because they see you have brought together multiple disciplines to your successful scientific program.
Yeah, well, we've never met, but I got a grant from your institute, so I feel I already know you.
I didn't even look that up. I didn't even look it up. So no, but I think it's an important theme, and I think it's also a relevant theme looking into the future, which is part of this theme, a part of this panel, is this idea that, you know, for a very long time, I don't think mixing was either thought about or embraced as much as it has become now, and it's actually, it's so important to stimulate. We do a lot of that at NIH, but HFSP does this now on a larger global scale. And that's really, I think, an important thing to recognize and to foster.
Absolutely. I think Victor mentioned too, convergence as well, didn't he? Yeah. So, Henry, did you want to comment on that? On bringing those different fields together and bringing them together to bring up unique questions?
I completely agree with what Eric said.
So we've got a little bit of time left. So one of the things that we're challenged with at NHMRC is identifying, we've got limited funds and we have to identify the very best research to fund. And that's, I think, a challenge all funding agencies have. How do we rank, how do we identify the very best research? And in the end, no one agrees with you. I mean, recently Apple Music ranked the top 100 albums and no one, top 100 pop rock albums, and no one agreed with that.
What was the top one? I don't remember. Okay, sorry.
No, I don't remember. It was an obscure album, actually, but I don't remember. Someone in the audience probably does. But I guess and Sgt. Pepper was was not in the top 10. So yeah, I had some concerns about that. But anyway, getting back to science, I just asked the three of you to think about what characteristics are we really looking for if we're looking for truly imaginative, unique science that we're going to fund? And Henry hasn't answered any question yet, so I'm going to ask him to answer that question.
So let me try an actual answer. I think finding a good science project is like finding a hit in music. You can't synthesize it really, but you know it when you see it, and you can feel it when the idea comes. And then, but not everybody will agree, right? I mean, not everybody has the same taste in music, not everybody has the same taste in science. But I've come to the point where I've sort of say, well, this is interesting to me, and I'm going to try to get that funded and convince people to fund this. And I really struggle with the trying to put it together like Frankenstein's monster, where every piece, there's so many pieces which are disparate but somehow have to come together. Yeah, it's an extremely challenging thing, but you have to get off the beaten path in order to come up with something new which actually moves the needle and is different.
By the way, Steve, you said, you asked earlier, some of these basic science discoveries leaning into health and health care. You know, one of the things we're certainly seeing, watching, genomics in particular find its way into healthcare is there's not a single answer because there's not a single healthcare system around the world, right? Every country is different. And so once again, to bring up this theme of the value of interdigitation and international collaboration is really recognize that every country is implementing healthcare differently, and how they are adapting to a new technology that's rapidly finding relevance in healthcare is like hundreds of different experiments going on around the world. And that's also really important to do.
Just going back to the data issue, perhaps I can ask, what's been Japanese response to the data issue, the data sharing issue? Certainly in Australia we have a lot of problem with getting people to share data across states, across provinces.
Yeah, certainly we all, AMED is very concerned about the enhancing the data DX types work, and particularly for the whole genome analysis data. And sometimes it tends to just trying to get the data, but the most important thing is how you can use these data, so this is a point we are really placing for the DX system, yeah.
Yep, no, that was good, thank you. So we've got about 3 minutes left, so I'm just going to ask each of you for your final comments. And I guess I'm just going to go back to the point I made right at the beginning, and that was the Economist article that came out last year that suggested that perhaps we were being less innovative than we had been in the past, and they drew a graph showing innovation going down, but research going up, but truly innovative research going down. Just want you each to comment on whether you think that is the case, and And is there anything that you would do about that? So we'll start with Henry.
Yeah, I think it is getting harder to make progress in research. Like the easy things have always already been done. And I tell my students, if it would be easy, I would do it myself. And so, yes, there are more people doing it. It gets harder and harder to figure out what hasn't been done before. It gets harder and harder to bring different things together, be on top of all the other things going on, and coming up with an idea which is not already in the literature 40 years ago, which happens to me frequently. And so it is a struggle, but it's a good thing, right? I mean, it's the sign of success, and I think we're just gonna keep on going on and try to make great new science.
The problem I have with that generalization is that either it lumps all of biomedical or all of life sciences research into one stereotypic package and says there's not as much innovation. I just would flatly reject doing an analysis that broad. I would readily admit if you stratified it across 20 sub-disciplines of life science, I'm sure some have periods of time that are more or less innovative. Some surge ahead, then they hit a bit of a barrier, and then they wait for a technological surge, and then and then other ones surpass it. I think it's highly heterogeneous. I think if you look in some sub-disciplines, the amount of innovation and the amount of advance is breathtaking. I think we could all give examples of things we never thought we'd see in our lives, let alone our careers, and here they are now in regular use. And yet other things may have not advanced as much because they haven't had the fortune of technological surges or other things that have advanced it. So I maybe if you average it out, I would reject it. I don't think it's true, and I think it's because you're lumping everything together.
Do you want to make a comment? So we might, 16 seconds to go. So we might stop there. I guess my response to the Economist paper is that we do, as funders, have to be mindful of what we're funding, make sure we're not funding safe research, and I think that is a big danger, particularly for national funders. I think we have a tendency to fund safe research, and I think it goes to the HFSPO really, that it's organisations like this that fund the unsafe research, the dangerous research, that will ultimately make that graph go up and create innovation. And so, but I think it's been a really interesting conversation. I thank you all. I ask the audience to have a look at the Apple list and see what albums they think should be in the top 100. And encourage everyone to stay around for a drink and something to eat. Thank you very much.
As you all would understand, as the Secretary General, I would agree for this last comment of Steve. Thank you so much. Anyway, thank you. It was exciting, and I will not stay long. I just think once more thank you to all of you. There is a reception and there is a lot of drinking and fooding, so please join us there for interactions. I think we had a fascinating afternoon. Thank you all. At least I feel energized even more than I was for this organization by this afternoon. So thank you so much and see you all around.